Trigonometric substitution is one of the more difficult techniques for integration. So I have a different way of looking at it. Look at it more geometrically and trigonometrically than I do just by memorizing formulas. So here's what I have for a basic setup. Three different kinds of problems. One I call the simple sign. And that is applied when you have an integral of the form of the square root of a squared minus x squared. For instance, like the square root of 4 minus x squared. So that a is a constant. And what I do is I build a triangle where I let the sign be simple. In other words, I put a fraction where you have the opposite side being x and the hypotenuse being a, the square root of that a squared. Multiply both sides by that a, and we have a piece of algebra x equaling a piece of trig, a sines of theta. Now, whenever I have the sine of theta, I use the cosine of theta. So if I look at that triangle, the sine of theta in that picture is x over a. By using Pythagorean theorem, I get the square root of a squared minus x squared. So the cosine, being adjacent over hypotenuse, is the cosine of theta is equal to square root of a squared minus x squared over a. Multiply both sides by a, and we get a piece of algebra, square root of a squared minus x squared, equaling a piece of trig, a cosine of theta. From there, I do a replacement of all the pieces in an integral, which you can take a look at one of my examples on the solutions to see how I do that. But basically, then the other two forms are exactly the same, except you change the trig function. So number 2, simple secant. That's when you have an integral with a square root, square root of x squared minus a squared. So it's the backwards of the simple sign. Then you let the secant be simple, x over a, algebra x equals a secant theta. The sister function for secant is tan, so I build a triangle, make the secant simple, and the tangent of theta ends up being the square root of x squared, minus a squared over a. And then algebra square root of x squared minus a squared is equal to a tans of theta. Finally, for the simple tan, that's when you have both being positive, so an integral of form a squared plus x squared, or x squared plus a squared, and then you just let the tan be simple, x over a, x is equal to a tan theta, pull out the sister function and get secant of theta is equal to square root of a squared plus x squared over a. And again, then your root is equal to, or the square root is equal to a secant of theta. And again, then you replace all the algebra pieces with trigonometric pieces. And if you always want to see an example of that, look in my solutions on Blackboard.